This movie takes the example presented in the previous lesson and programs it as an example using transaction processing. The main line shows the program creates a table and adds some records to it. This is the gold ingots trading table with only 2 entries that I showed you in the previous lesson. The program then executes or attempts to execute a couple of sales and shows you the results in the table after each one. At the end, the table is dropped and everything is closed. This is the method that creates the table. It gets a connection to the database in just about the same way as we've been doing in the past, but then something new has been added. This call to set AutoCommit is made with an argument of false. By default, AutoCommit is set to true, which means that every update statement made is committed automatically by being finished in the database. With AutoCommit set to false, nothing happens to the database automatically. This program will have to include the commit call to have anything actually take effect. Now, notice that this is done at the connection level, so it affects everything done in the program through that connection. Notice right here, there is an execute update method that creates the new table, but it doesn't actually do anything until this call is made to commit. Once this call has been made, it has been done and you can no longer take it back. Before that, you could actually say King's X and take it back, and I'll be showing you how to do that here in a minute. Here are a couple of calls to execute update and add some records to the file. Remember, there is no automatic commit, so it's necessary to call the commit method to have it actually take place. The show table method is fundamentally the same as it has been in the previous programs. It loops through the entire table and prints each row. In this case, there are 3 columns in each row: the name, the cash amount, and the number of ingots. This is the sell method, the one that transfers cash and ingots from one row to another. Now, this could be updating lots of different tables, but I just use this one table to keep it simple and show you the fundamentals of how a transaction works. To make a sale, we have to update the information in 2 rows, the seller and the buyer. We start with the seller. The ingots sell for $100 each, and the arguments passed to the method specifies how many are to be sold, so we make the adjustments to the new values as the numbers are retrieved from the database. Then an execute update method is called to update the database. Now, this statement has not been committed, so nothing is done to the database yet. The command to update is just held for the moment. If this is not a valid transaction, that is, if this guy doesn't have enough ingots to sell, the whole transaction is bogus and can't go through. A call is made to the connection method named rollback, which deletes every pending command all the way back to the last commit. It's King's X. Nothing happened. It's all erased. However, if everything is okay up here, we continue by getting the record of the buyer. In the same way, we update the count of cash and the count of ingots in an execute update method call. However, if there is not enough cash to make the transaction, the rollback method is called, which undoes everything, and the return is made with nothing having been done. It's all or nothing at all in this one. Let me make a side note here. This is one of those business rules. Your program may want to check the guy's credit and put the ingots on his charge account. Or maybe you want to complete the sale for only the amount of money that he has. You could wind up changing several other tables in here. But those are business decisions, and that's why business rules get built into the code. At any rate, nothing will happen in the program until there is a call to the commit method. The only methods left are the ones that drop the table and close the connection. Notice in the drop table method that a call is made to commit after the table is dropped. This has to be done because auto commit has been set to false and nothing gets done in the database unless you say so. Now here's what the program looks like when you run it. Notice that the first sale met all the criteria and went through, where the second transaction was found to be faulty and was not executed. What you can't see from this is that the transaction was completed safely. There is no point at which a system crash or a program failure or a loss of communications with a database could cause a corrupt file. There's one other problem that this program does not address. If another program is attempting to update the cache and ingots fields after you've read the values, that could still cause an error. This is a locking problem, and we'll be looking at that in just a bit.